Stuff we add to this. Add to the notes from last time. We're gonna go over the stuff that we did last time quickly, so you might jot down some things if you didn't get it last time. Again, two different kinds of tests that we'll cover. So these are the large samples that we're covering. Remember, a large sample again is anything over 30. Find the p-values and test them using a z-test. That's just where you compare the p-value to the alpha, what we did right here, or rejection regions. Two different ways to do this. Use the rejection regions, you got to find the critical values, or find those values on your graph, and then deciding whether it falls in there or not. Right-tailed, left-tailed, two-tailed, you got to know that. The first one is called, and you'll probably never hear me say it, because I always forget, a decision rule-based p-value. That's this. When we're comparing p to alpha, you're doing a decision-based test. P is less than or equal to alpha. There, look, my alphas look better, don't they? P is greater than alpha. So less than or equal to, does it still look like an A? It does. Alpha, fish. P is less than or equal to alpha, you reject the null. Greater than alpha, you fail to reject the null. Talked about that last time. We just did a few of these problems.
What does this do with reject and accept instead of fail to reject?
We talked about that because if you fail to reject, what are you saying?
That you don't fully, like you're not accepting it, but you're not getting rid of it.
Right.
It's still an option.
It's just being politically correct. I'm recording, so I can't say the thing that I said the other time about somebody being unintelligent and stuff when I said that. After determining the hypothesis test standardized test statistic, that's your z-score. Use the chart to find the area. Then that area is what you compare to your alpha. That's the p-value. P, remember, is probability, same as area. The reason it's the same as area, what you're doing when you're looking at the p-values is you're saying, what's the probability that the whatever we're looking at falls in this red region compared to what's the probability that it falls in the white region? That's why it's p, probability. What do we know about the underneath the whole graph? Hint for your final exam here. What's the area under the whole graph? 1. So what we're saying is this area out of 1, that's our rejection region. We're comparing those. For a left-tailed test, the area is just whatever's on the chart. Left-tailed, you just use the chart. Right-tailed, remember with right-tailed you got to take the area, or 1 minus the area that it tells you on the chart. And then for two-tailed, what do you have to do? Multiply it, find it on the chart, and multiply it by 2. So 2 times the chart. Left-tailed, just use the chart. Those are the easy ones. Right-tailed, 1 minus the chart. Two-tailed, chart times 2. Find the p-value for a left-tailed. Left-tailed's the easy one. So all we do is look up this number right here on the chart and decide whether the answer we get, the P, how it compares to the alpha. We're looking right here again. If the P is less than or equal to alpha, then we do what?
Reject.
Reject. Greater than alpha, fail to reject. We look on the chart for that number, and our area is 0.0129. We compare those two. It's greater than, so we fail to reject. On this one, two-tailed. Remember, with two-tailed, we look up the area, and then we're going to times it by 2. So we take the area and we times it by 2, because you got a part of a tail over here, or you got a tail on the left side, you got a tail on the right side. So that area is 0.0162. This one, they actually found the right-tailed area first, so they had to subtract from 1 on the chart. Once we double that, we compare it. This time it's less than, so we reject it all. Yep.
Can I use
The z-test for the mean, your test statistic is your x-bar. Your standardized test statistic is your z-score. You find your z-score by doing this. The homework tonight's going to do more of that. You're going to have to find the z-score. So you're going to have to be able to find that z-score. So if you don't have this written down, and this next slide, if you don't have them down, these next couple of formulas, make sure you get it down. To find the z-score, remember you take the sample mean minus the population mean divided by the standard error. Sample mean minus population mean divided by the standard error. That's going to give you your z-score. That's telling you where you're falling at on your normal curve. Whatever your test statistic is, here it's your x-bar. Your z-score is your standardized. So this is, when we talked about this earlier this year, your x-bar is your raw scores. This is your standard scores when you change it over. So you got raw scores, those are the original scores. Then you got your standard scores. To find C, that's the formula right there. Remember this bottom part? That's the standard error. If you didn't get that down last time, make sure you get it down, because that's what you're going to use more tonight. You're going to have to find your z-score, use the chart, and then compare. Remember this sigma sub x-bar, that's talking about your standard error for your x-bar, for your sample. So using the p-values, for a z-test, for a mean, first thing you do, state your null. This is what you're going to do tonight on the problems. State your null and your alternative hypothesis. That's step 1. Then you're going to identify your alpha, your level of significance. Step 3, find the z, find your standardized test statistic. That's your z. That's like your critical value, whatever. Find the area that corresponds to that. You're going to use the chart for that. Remember, it's the standard normal distribution chart. Fifth step, find the p-value. That's what we were doing when we were looking at the chart before. You got 3 different things it could be. Could be a left-tailed, could be a right-tailed, could be two-tailed. Left-tailed, remember this is just use the chart. Right-tailed, you got a 1 minus whatever it says on the chart. two-tailed, you gotta take 2 times the chart. Number 6, make a decision to reject or fail to reject the null hypothesis. So you're going to decide if you're comparing them this way. Here we reject the null hypothesis. Here we fail to reject the null hypothesis. Just make that decision. Seven, interpret the decision. When we interpret the decision, that's where we use this chart. This will help Grant out right here. Got to remember where your claim's at. If your claim is the null, these are the 2 explanations you could give. If you reject it, then you say there's enough evidence to reject the claim. If you fail to reject it, you say there's not enough evidence to reject the claim. If your claim is the alternative hypothesis, then these 2. So that's what you're going to do. So we're not, remember when we want to, let's say we have a certain claim. If we want to reject it, or I'm sorry, if we want to support it, we put the claim in as what? The alternative. If we want to reject it, if we're trying to go against what this company's claiming, we put it in null. In an advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. A random selection of 36 delivery times has a sample mean of 28.5 minutes and a standard deviation of 3.5 minutes. Is there enough evidence to support this claim? This is what you're going to be doing more tonight on. We didn't do this last time on the assignment. This is more what you're going to be doing tonight. Things you need from this. First, we need to write what their claim is. Mean delivery time is less than 30 minutes. So their mu, they're saying their mu is less than 30 minutes. And then from that, we're going to write a null hypothesis and an alternative hypothesis. Exactly what you got to do on the homework tonight. So you're going to write a null and an alternative. Our null hypothesis, remember your null hypothesis has to have the equal to part in it. So instead of mu is less than 30, what's our null hypothesis going to be? Mu is what? Greater than or equal to 30. What's our alternative hypothesis going to be? And that's the claim. And make sure you mark it that way so you know which one's the claim. Because that goes right back to our little chart that we just had a minute ago. And that tells us how we're going to make or decide or what we're going to say after we get done with all this. The other things we need here, this is our standard deviation. So that's our S. This is our X bar. And this is our alpha. We need all that stuff so that we can use those formulas that we just had a second ago. And I'm going to run out of room here. So I'm just going to go to the next thing. So we did this. We found those greater than or equal to 30 minutes, less than 30 minutes. Remember, this one is your claim. I'm not sure why I didn't put it on there. Too lazy, I guess. Our alpha, 0.01. And then we got to find our test statistics. Somebody help me out with that formula. What was that formula to find Z?
Sample mean minus population mean divided by standard error.
And what's that? How do we find the standard error? turbo over square root of n, right?
Isn't that the standard error?
Yeah, that's the standard error, but I
Use
want,
the standard error to find the standard error.
well, I want to know what the formula was to find the standard error.
Oh, see, that's what, I got it wrote down, and you said find this, I was like.
I believe you. I
Mhm.
just didn't understand what I said.
Couldn't find standard error.
So, do we know-
Standard error.
Do we know the sample mean?
Yeah.
Yeah, it was 28.5 or something, wasn't it? So 28.5 minus, what's the population mean? What was their claim? 30. Over, do we know the sigma here? Population standard deviation? No, but we know the sample standard deviation, and that's what we use. What was the sample standard deviation that we had on the last slide? 3.5 over how many items did we take? 36. So we take square root of 36. Some of this you can do before you ever stick it in the calculator. What is square root of 36? 6. And then could you just divide 3.5 by 6 and have that on the bottom so that you don't have to
Yeah.
use parentheses and everything? Grab your calculator, 3.5 divided by 6. And I got 0.58333. Subtract this, 28. We could probably do that in our head. What's 28.5 minus 30? Negative 1.5. And then you're just going to divide those two. Negative 1.5. Negative 1.5 divided by 0.5833. And on my calculator, I'm going to go ahead and punch in a bunch of 3s because it had a 3 repeating. And that'll give us a more precise answer instead of rounding it off all the way back through. And we end up with z equals, remember this is our test statistic, which is our z, negative 2.57. Once we know our test statistic, we're going to compare it to our we're going to look up on the chart and find the area. First thing we need to do is decide whether it's a left-tailed, right-tailed, or two-tailed. How are we going to decide that? If I'm looking at my thing here, think about what you have up here as your null. We want what? What's this tell us? Greater than or equal to, right? So are we going to be on that side if we're rejecting, or this side?
The right side.
Right side? Let's see what we got here. We got all this stuff. We found that negative 2.57. Remember here, I had to think about this, that's why I need to see that. If this is we're trying to either decide whether to reject or fail to reject this. We don't care where the claim's at really. We're trying to decide this. This is telling us if we're greater than or equal to 30, if we're bigger than that, are we accepting it or rejecting it?
You're accepting it.
Accepting it. So this tells us that we have a left tail. If it was the other way, then we'd have what kind? A right tailed. And if it's equal to and not equal to, we'd have two tailed. So that might be something we want to write down somewhere. If you have this in your null, left tailed. If you have this in your null, right tailed. If you have equal to in your null, then it's two tailed. Left tailed, right tailed, and two tailed. we look up this, once we have the Z, we look it up on the chart, and it tells us this area, 0.0051, that's our p-value, and our alpha was 0.01. We compare those two. What symbol goes in there, less than or greater than? Less than? Greater than? Less than? If it's less than, what's that tell us to do? Reject the null. So that's our decision. We reject the null. Now remember, the claim was the alternative hypothesis. So, huh?
Are they ever going to be equal to?
Not very often. I mean, if you wanted to put that in there,
No, like, I mean, like, what if they're exactly the same?
if they're exactly the same, then we go with this one.
Oh, all right, yeah.
We reject.
Or equal to, yeah, I guess, but
All right, but I just don't write it down here because not very often is it going to come up exactly the same.
yeah.
So if you just remember less than, reject, greater than, fail to reject, it might make it a little easier. We don't want Jesse to have to remember that equal to part. He's already complaining too much to remember. So we reject the null. What's that tell us when we reject the null? At a 1% level of significance, you have sufficient evidence to conclude the mean delivery time is less than 30 minutes. So this time, we're rejecting the null, but are we rejecting their claim? No, we're agreeing with their claim. Does that make sense? So if we go back to, I hate to do this. I'm just going to end the show here. If we go back to this chart right here, our claim was the alternative hypothesis, and we rejected the null, so that tells us there is enough evidence to support the claim. So the pizza delivery companies claim we can support that they're going to be less than 30 minutes on the average. That's not what I want to do. You think the average franchise investment information shown in the graph is incorrect, so you randomly select 30 franchises and determine the necessary investment for each. The sample mean investment is $135,000 with a standard deviation of $30,000. Is there enough evidence to support your claim? So you're saying that you think this is wrong. So that's going to be your claim. If we're trying to show that it's wrong, then we want our claim to be where? The null or the alternative hypothesis? So if we're trying to say, hey, this is wrong, we want the claim to be in there. The standard deviation's 30,000. Look at these big numbers because this is what you guys got coming up here in the next few years. I hear all this stuff on the radio about the investment people saying, contact John Brown if you have more than $1 million saved. I'm like, you got $1 million saved? I don't either. I don't know who has $1 million saved. I had Dalton. His dreams. I have IRAs and stuff, and I don't have $1 million in them.
Keep putting 5,500 in every year, your money will be vacant.
Got like 20 bucks in
10
my
years.
savings account.
In 10 years, you can have
I spent it
over $100,000
yesterday.
in a rock.
So this is our mu. They're saying the mu $143,260 equal to that, not equal to. Are we going to have one-tailed, two-tailed, left-tailed, right-tailed? What is it? Two-tailed. Remember that. Our alpha, we want to be within 0.05. We'll find our test statistic by doing all this stuff. So that's our z-score right there. Z is negative 1.5, or negative 1.51. That means when we're looking at our graph, and the graph probably come up here in just a second, we're right about here at negative 1.51. We need to find that area right there since it's, or I'm sorry, we're gonna find that area right there, but it's also gonna be on this side. So we could either be here or we could be over here since it's two-tailed. What are we gonna have to do to this area once we find it on the chart? Multiply by 2 because it's a two-tailed. That's something I bet that they do here in a second. We got our two-tailed there, they multiplied it by 2. That was the area, and multiplied it by 2 to get that. Then we're just gonna take that number and we're gonna compare it to this. So we got 0.1310 compared to 0.05. Less than or greater than?
Greater.
Greater than. What's greater than tell us? Fail to reject the null. So we fail to reject this null. I don't remember what the actual claim was, and I didn't write it down here. So we fail to reject the null. At a 5% level of significance, there is not enough sufficient evidence to conclude that the mean franchise investment is different from. So this must have been, let's see, if we failed to reject the null.
Should be the null then, right?
So this was our actual, this was our claim.
Yes.
And we can't say, so in other words, we can't say that the company is lying to us. All right, this might be new. Great, you ready? This is probably new. I don't think we got this last time. Rejection regions or critical regions. The range of values for which the null hypothesis is not probable. So this time what you're actually going to do is you're going to draw those critical regions. Draw the graph and decide, hey, does it fall in there? The range of values for which the null hypothesis is not probable. If a test statistic falls in the region, the null hypothesis is rejected. So when we're looking at our normal curve here, this is our region. If it falls in there, we reject it. If it falls out here, we fail to reject it. And we're looking at that critical value ZO. We're going to find those critical values. Some of these you can actually use your calculator on. So you're just looking at that if it's two-tailed. And if it falls in here, you reject it also. So these critical regions. Instead of just comparing P to alpha, I don't know, you might decide one of them's easier than the other one and use that most of the time. This is how to use a calculator. Stat, test, z-test. And I think there's more than that on there. Seems like I was looking at it yesterday and there's more. Stat, test, go down to, z-test on mine on the old calculator is number 1. Does anybody have one of the new calculators? Where's z-test at?
Pretty sure.
Number 1 on the new calculator?
Pretty sure.
I'm gonna write some extra stuff down here that I should have put in here that I didn't. So, usually I give you a better list than this. This list isn't very good. It's the first thing you do, second thing you do, third thing you do. Fourth thing you do is decide whether you're putting in stats or data. Remember stats, if you're putting in mu, sigma, all that stuff, data is if you're taking it from a list. So if you made out the list and stuck it into the calculator, then you can say just use list 1 or list 2, list 3, whatever. Fifth thing on the calculator After stats, we put in mu. Sixth thing, you put in sigma. No, that's alpha. Put in sigma. Seventh thing, we put in x bar. And you can see all this on there. Eighth thing, you put in your n. Remember that's your number in your sample. The only reason I'm even writing down these is because I wanted to get to this ninth thing. On the ninth thing, you're telling the calculator, in your HO, you got to tell the calculator whether you got, not in your HO, in your HA, I'm sorry. In your HA, you got to tell the calculator whether you have not equal to, less than, or greater than. So you're telling the calculator if it's one-tailed, left-tailed, right-tailed, or if it's two-tailed. But this is your HA. You have to tell it what's in the HA. So you still have to write the HA and the HO out and then tell the calculator what's in that HA. Not equal to, less than, or greater than. Then from there you can go down to calculate and just hit calculate. Finding the critical value, specify the level of significance, find your alpha, decide whether it's left-tailed, right-tailed, or two-tailed. Find the critical value, or find your ZO. That's your critical value. If the hypothesis test is left-tailed, then you just find the Z-score on the chart. So on this one, you just use the chart, whatever the number it gives you on the chart. Right-tailed, you got to do 1 minus the alpha to find your Z-score, or to find that area. And then if it's two-tailed, you do 1 minus 1/2 times alpha. So these are sort of new. You're sort of going backwards from what we were doing with this stuff over here. So to find those critical values in a normal distribution. If this goes somewhere else, I'll switch it back. Next. Give you a second. This is what you're going to do to use the chart. Instead of comparing alpha to P, these are the steps you're going to do to find the critical regions and then decide if it falls in that critical region or not. So yes, Grant, that might be something that might be helpful. I won't even say it to Jesse because he already knows it might be helpful. He's just picking his hand instead of, right? So when he takes the next test,
Instead of getting 100, I'll probably get an 80.
yeah, just like all the other hundreds. Let's do a little sample. I'll compare Carson's grade to your next test. Because Carson's writing and you're not. So,
Look at these notes. I got
well,
everything.
but I'm telling you, this is important. So we'll write this down. Writing, not. And we'll do a little sample test and see what falls in there. Carson's writing,
It's just smarter.
Jesse, not.
Carson's just.
We'll take that into consideration. We can use a level significance of like 10%. We'll even do that. Alpha, we'll say alpha is 10%. So we're going to take into consideration that he's smarter, since you said that.
Everyone knows it. Might as well.
And so if it, that's why we use a big level significance. We'll say, it's just because he was smarter than. So we'll make the region that could actually come out to where my claim is true little smaller.
You're mean to me.
Everybody out in the world next year is gonna be so sweet and nice to you. They're gonna say, "Oh, Jesse Schaefer, we've heard all about you." Driving truck, your dad knows. Yeah, I bet your dad, he probably comes home in a bad mood every now and then, doesn't he? Stupid people the doc had to deal with them, they're idiots. You ever heard anything like that?
No.
Don't lie to
People
me.
From his dispatcher.
Huh?
His dispatcher.
Oh, that's who he complains about, is his dispatcher.
Yeah, and he
That's what
takes it
everyone
out on me.
complains about.
Last night he's taking it out on me, so I got the dog shock collar. I was shocking him, it's hilarious. He's punching me.
See, he's not punching you in the right spot, but he's still under that old adage, don't leave any marks. So you hit like in the arm or in the shoulder or something, in the chest. It only takes one punch.
He used to chew this gum, and it had this real sharp plastic, and he'd cut me with it. And it would like, you couldn't see it at first, but like the next day it'd swell up and turn red.
So on this, our steps, specify the level of significance. They're probably going to tell you that. Decide whether it's left-tailed, right-tailed, or two-tailed. Find the critical value. Find the critical value using all this stuff, all those formulas and everything that we've been doing. Remember, if it's left-tailed, you just take the number directly from the chart for the area. If it's right-tailed, we got to do 1 minus that. Actually, I sort of wrote this wrong because on this, when we're doing it backwards, you're using that alpha as your area. So we do 1 minus alpha, that's going to give your area. You find that area in the chart. Sketch it. So you're going to sketch your little curve. If it's left-tailed, you're going to find this here, that area that you just looked up in the chart. You're using the chart backwards. It's going to be there. You're going to find that z-score, whatever goes along with that area. So you're using the chart sort of backwards. Shade in the rejection region or regions.
Actually, I really just don't try in school. That's it.
You were trying there for a while. I was pretty impressed. I think I might even said that during class a couple of times, didn't I? I was impressed that Jesse was doing so well. Probably accused him of cheating and right after that.
If I try, I could do good. Which I don't like not try at all. I try a little. I try enough so I can get by.
See, that's, I'd rather not see that, because I'd rather see you, when you get out, even though maybe none of this stuff means anything to you, and it'll never mean anything to you, and that's fine. But when you get out of here, and you're used to that, just trying enough to get by, what are you gonna do out in the real world?
Well,
Trying
the
enough
reason
to
why
get
I
by.
try enough to get by is 'cause I got a lot of stuff to do at my house. So I just,
But see, that's, I know how it is, because I sat in this same exact classroom, and I know what I did here, and I know that, hey, you know what, if I would have done a little better, number one, my wife wouldn't have been complaining up till about 5 years ago that she was still paying off my student loans. Alright, number two, would I be in a little better shape than I am right now, probably, as far as finances go? Yeah. I wouldn't be working here at Trail. Shut up right now, shut up. This will help you, this chart. I don't think we got to this last time. These are the levels of significance. If I can get it. raised up area, yeah, this would probably be a good thing to write down. I don't think it's on any of the charts. So this way, instead of having to find the Z-score, these are the ones that we use most of the time, you can just use this chart. So if we're doing it, if our alpha is a 10%, if we're doing it at a level of significance of 10%, if it's left-tailed, that's your Z-score. If it's right-tailed, that's your Z-score. It's an alpha.
What is this alpha next to it?
Alpha. So these tell you, if you have this is like the little chart that we used here. Remember how much easier that made the last couple of chapters with that little chart? Because then you didn't have to go through the big chart and look up everything. Those are the ones that we're going to use. Remember with the two-tailed ones? Two-tailed, you got a positive and a negative. This Z is probably actually, I'm trying to think, it probably should be Z sub 0 because that's actually your critical value. So you're on your graph, you're on your normal curve, and you're saying, all right, if Z is at negative 1.28, somewhere about there, that's negative 1.28. We draw the graph, we shade in this area. This is our rejection region. The white is where we fail to reject.
Mr. Eversole, I'm supposed to ask you about something.
Very good to start now.
Is that education related? Don't lie.
Possibly.
Don't lie. You got about 6 minutes, Grant, to think up a way to make it educated related so that you could actually ask me. Got to think first. So again, use this if we're using the rejection regions. Find P, you can find P using the calculator also. That's what the calculator was there a few minutes ago. Just use your brain a little bit and decide, okay, all right, which way, what am I going to do here? So everybody got that chart?
Yeah.
Dawn, you got it?
Yeah.
So find the critical values rejection region for a two-tailed test with alpha 0.05. This is what we do. Doing two-tailed, we're looking for these critical values right here. What'd it say on the 0.05 if it was two-tailed?
Plus minus 1.96.
So what's this number right here?
Negative
Negative 1.96. What's this one?
1.96.
Hopefully that's right. They actually used a chart instead. See if they come up with the same thing. Oops. Hit the wrong thing. 1.96, negative 1.96. They actually went through all the headache and went through and used the chart backwards and did all that. It's a lot easier. I'm saying they used the chart. They used this chart and did it all half of alpha and did all that when we could have just used that chart that we just wrote down and made it a whole lot easier. To use rejection region, conduct a hypothesis test, calculate standardized test statistic Z, standardized test statistic is in the rejection region, then you reject the null. If it's not in the rejection region, then you fail to reject the null. We've been talking about that the whole time. So if it falls in here, we reject it. If it falls out here, we fail to reject it. So what we're gonna do is the same thing over again. State the claim, HO, identify alpha, sketch the sampling distribution. Notice on this one, sketching the sampling distribution's up higher because now you're actually using the graph to decide this instead of just using it as a picture to help you. Determine the critical values. We use that little chart that you just wrote down. Determine the rejection region or regions. Find the standardized test statistic. We're going to have to use that formula. Make a decision, reject or fail to reject. Interpret that, use that little chart that we had with the 4 things on it to decide whether to reject or fail to reject. That's your assignment, page 381, 4 through 24. That's the same as what we did last time, sorta. All right, just the even numbers instead of the odds. These here are going to be the ones, the actual word problems where you're going to have to probably put a little thought and effort into them. First, if I run this across here, we won't trip over it, right?
No.
Get out of Sean's way, 'cause I think I'll trip over it.
Yeah, I probably looked around this morning, I was walking through the road and my foot hit dry spot. That was one like this. And the bottom of my feet were really dry. And the floor was all wet and I had dry spots in the car. Like, lots forward. Why do you have bad legs?
We're getting ready to do sine, cosine, tangent and stuff.
Oh, I love that.
Geometry, so I wanted to try to be able to do it on the calculator.
Thank you.
That's all. I can read it.
Yeah, big boys do. Still looks a little dark. I wonder why it looks so dark. It's black. Spring maybe.
And then you see it all over.
Should be dirty spring.
I think it's fine. Yeah, look at that.
You can see the other deck?
Oh, yeah.
Can you not see it over there?
Yeah, it just looks dark around the edges.
It looks perfect over here.
Does it? Yes. They're not standing too close to it.
You take that home, it'd be worth a couple grand, couple years. Look at this. It's like 2020 technology. Oh. Saving your energy.
I was alive 32 years ago.
Oh, yeah, that's what I'm talking about.
You spelled it wrong.
Huh?
You spelled it wrong.
Now what are you gonna make fun of it?
wasn't gonna make fun of you. I wasn't gonna make fun of you.